Okay, I am going to demonstrate to you now the method of optimizing a portfolio using the Sharpe ratio using Excel. All right, so I have already collected this information. How this is collected and how the certain numbers are calculated here. You can watch my previous video. So we have the monthly closing prices of Tata Motors, HDFC Bank, TCS, and Apollo Healthcare Limited. Apollo Healthcare Enterprises Limited, and the stock price data has been collected for last 16 months. Okay, and using this we have calculated the returns. The monthly returns are calculated, and these monthly returns later are converted into average monthly return. We calculated monthly variance, monthly standard deviation. Then we took the annual return and annual variance and the standard deviation. Okay, we've taken the standard deviation and finally the coefficient of variation. This information is what I have collected so far. So using this information, I'm going to demonstrate to you now how we can build an optimal portfolio that will give us the maximum Sharpe ratio. Okay, basic understanding or basic requirement to understand this model is that you understand the concept of portfolio theory. Okay, especially the modern portfolio theory. All right, so anyways, I'm going to hide this now. First point, and I'm going to hide this. Okay, secondly, I need these 4 stocks. I'm going to copy this and probably paste it here. So basically I have the list of stocks here, and let me write down the return that they're generating. Yes, I'm making an assumption here that the stock will generate this return going forward also. Okay, because this is based on the past 5 years. So what we can do is we'll have to manually do this. Okay, so the annual return of this is this. Okay, HDFC Bank annual return is here, and TCS annual return is 26%, and AHL annual return is 31%. Okay, so we have copied the returns here. This is my returns table. And then I am also going to take down another information which is called risk-free return or risk-free asset return. Okay, risk-free return. So risk-free return, as of now, I'm assuming it to be around 5.50%. In fact, you can take this information also from internet. So you can go to, let's say, RBI website. So a risk-free asset is an asset which will which has absolutely zero risk of any fluctuation in the expected returns. So you can see the government security rates, the yield on government securities. Say for example, if you're talking about next 10 years, a 10-year bond is expected to give around 7.36% right now. Okay, or if you're planning for a 1-year level of portfolio building, then you can take 5.92%. So depending on what is your period of study, you can take. So right now I'm going to take 7.3656% as my risk-free rate of return. Okay, so yeah, this is my risk-free rate of return. So much information has been collected now. Now I will also need what is called as covariance between Tata Motors and HDFC, Tata Motors and TCS, Tata Motors and AHL, then HDFC and Tata Motors, HDFC and TCS. So basically for all possible combinations, I want covariance. So for that, I will use the covariance matrix. Okay, covariance matrix. So first, let me take these 4 assets here. Okay, and probably I'll move it here, and I'll also copy them and paste transpose. So I have made a table now. Actually, it looks like a table, right? So here I will calculate the covariances. So ideally what I should do is, I'll just show you covariance between, let's say, HDFC Bank and Tata Motors will be COVAR. That is the formula for that, covar. You can take that, and then you have to select, HDFC Bank returns starting from here till the end. Then take the Tata Motors return. Okay, instead of doing that, selecting and I'll have to do it like literally 16 times. So because of that, what I'm going to do is, just give a second. Okay, so I'm going to give a name to this range. Okay, this range, I will name it so that it will be easy for me to refer there. So this range, what I've selected, I'm going to name it. I'm going to click here and name it as Tata Red. Okay, just Tata M Red, same name I'm giving. Okay, similarly, I will select this HDFC Bank and I will name it as HDFCB REIT. Okay. Similarly, I'll select this. Okay, I'll name it as TCS REIT, and I'll select this, and I'll call it as AHEL REIT. So basically, I've named the ranges. So I'm going to use those ranges that I have named to calculate these things. Okay, 1 minute. So this will be covariance between Tata M written, comma Tata M written. So it's a covariance between the same. Okay. So and then covariance between HDFC Bank and Tata, that would be COVAR, HDFC Bank REIT, comma Tata M REIT. Right. And then you can take covariance between TCS REIT and Tata M REIT. Okay, 1 second. I don't know if I have correctly selected this. TCS REIT and Tata REIT, right? Tata M REIT. And here I'll take covariance between AHEL REIT, that is the array, and Tata M REIT. Okay, this is what has been. These are the covariances for this. So similarly, I can calculate this. So between HDFC Bank and Tata Motors, I've already calculated that. So I'm going to link this. See, HDFC Bank and Tata is already there, so I don't have to repeat that. For HDFC Bank and HDFC Bank, I'll calculate again. So covar between HDFC Bank REIT, HDFC Bank REIT. Oh, sorry. Okay, then TCS and HDFC Bank, covar between TCS and HDFC. All right. Again, this is covar between AHEL and HDFC REIT. Perfect. Okay. And then between TCS and Tata Motors, I already have it. Okay, it's here. And between TCS and HDFC Bank is also available already, which is here. Okay. And between TCS and TCS, I need to calculate. So TCS REIT, TCS REIT. Okay. And here again, I'll type covariance between AHEL REIT and TCS REIT. That's it. And finally, AHEL and Tata Motors, it's there already. AHEL and Tata Motors is here already. And HDFC Bank, AHEL and HDFC Bank is also available already here. And AHEL and TCS is also available here already. I need to calculate covar between AHEL REIT, comma AHEL REIT. Okay, so this is my covariance matrix. Okay, just leave it as it is. You don't have to do anything else. All right, then let's come here. Let us create the optimal portfolio. Okay, optimal portfolio. So to start with, what I'm going to do is, as usual, I'm going to have these 4 stocks with me right now. Okay, and let us give an equal weightage to start with. Let us say all of them are 25% each. Okay, 25% each. So therefore, the sum total would be alt equals. So sum will be 100%. Okay, so leave this as it is. Okay, leave this as it is. Now let us calculate the expected return. Expected return from this portfolio. You can call it as RP. Okay, so expected return will be simply the weighted average of the returns with that of this. Okay, so I can calculate that simply by using the function sum product of this comma this. Okay, so expected return of this particular portfolio right now, if we invest 25% in each of these stocks, you can expect to earn 21.69% from this portfolio. All right, now, but again, is that the best portfolio? Not really. Okay, maybe we can rework on these weightages such that this return can go up. All right, so let's see that. That's what we're trying to do now. Then we'll calculate the standard deviation of the portfolio. Okay, SDP. So standard deviation of the portfolio can be calculated as, now this is where you need to use what is called as matrix multiplication. Okay, matrix multiplication. So I'm sure in your school days you would have learned matrix multiplication. So wherein you have a a column multiplied with a row, right? So that happens. So we're going to use that now. So let me so let's start with taking the transpose of this. Okay, so what it does is it basically the vertical arrangement will become an horizontal arrangement. That is one thing that I'm doing. Then I will multiply this, okay, this with m mult, this with an arrangement of covariance matrix. Okay, so I have this arranged in this order, that is horizontal order, and that gets multiplied with this matrix. This is a 4 by 4 matrix. This becomes a 1 by 4 matrix. So a 1 by 4 matrix gets multiplied with a 4 by 4 matrix. That is something that we're doing. And this whole thing we will multiply again. We'll again multiply this. I'm using m mult function. This whole thing I'll multiply with the weightages without transpose. Okay, so that 4 by 4 matrix and this, when we multiply, we get a 4 by 4 matrix again after multiplication. That I'm again multiplying with the weightages here. Okay, so that becomes thing, and this whole thing has to be put under square root. I'm putting it under square root. And now this is a very important step. Now after you write this formula, the important step is that you need to generally when we enter a formula, we just press enter after entering the formula, right? Right now you need to enter with a control button. Hold the control button and enter, because m mult, all matrix related operations or functions in Excel are array formulas. They're called array formulas, which are specially used for some special situations. All right. So therefore, whenever you enter a array formula, you will have to use control plus enter. Okay. So I'm holding the control button and then pressing enter. Okay. So it's still not working. 1 second. What's wrong? Okay, sorry. Control shift and enter. Okay, I'm sorry. It's not just control enter. Control shift and enter. Control shift and enter. If you enter and you go back to the formula, you see that there is a flower bracket here. Can you see? So whereas if I look at the sum product, there is no flower bracket. So that means this is a normal formula, whereas this one is a array formula. All right, so remember that, and we are using array formula to calculate the standard deviation. So the return on the portfolio is 21.69%. The standard deviation on the portfolio is 7.66%. Okay. Now let me calculate what is called as Sharpe ratio. Sharpe ratio is a Sharpe measure. What is called as? It is a portfolio evaluation formula, which is given by this formula. Okay, let me show you the Sharpe formula. It is portfolio return minus of the risk-free rate divided by the standard deviation. Portfolio return minus of risk-free rate divided by the standard deviation. That is a formula for Sharpe ratio. So higher the Sharpe ratio means the fund or the portfolio has generated higher risk-adjusted return. Okay, so that's what we're going to calculate, because see, when you are evaluating a portfolio, we cannot evaluate only based on the return or only based on the standard deviation, correct? Because investor wants maximum return, lowest risk, correct? So but you need a adjustment for that. So that is where we use Sharpe ratio. Okay, Sharpe ratio is definitely a better improvement over the coefficient of variation, because coefficient of variation does not take into account the excess return that the fund has generated over and above the risk-free rate of return. So that is being taken care by here. Okay, so Sharpe ratio, as you saw the formula, RP minus RF by standard deviation. So your RP is 21.69% minus your risk-free rate of return is 7.37% divided by standard deviation of portfolio. Okay, press enter. So this is my Sharpe ratio, generally expressed as a decimal. So I'm reducing that to decimal now. So the Sharpe ratio of this particular portfolio that we have built with the given covariance matrix, given return, and the chosen weightages for each of the stock is 1.87. And as you know, our objective is to maximize the Sharpe ratio, correct? So I want to rework on that, and I want to ask a question: what should be these weightages such that I will get a higher Sharpe ratio? For example, let me put 100% in Tata Motors and 0% in all the others. Oops. Okay, sorry for the break. Okay, so I was trying to tell you, so we basically had a 25% as the portfolio weightages initially given. That said that the Sharpe ratio will be 1.87. Now my question is there a way in which we can change this combination of weightages such that can my Sharpe ratio be maximum? For example, if I put 100% in Tata Motors and put nothing in the other stocks, my Sharpe ratio will be 0.5. Or maybe randomly I'm putting 75% here, 15% here and 10% here. Okay, then my Sharpe ratio is 0.86. So there is some combination of this weightage which will yield me a higher Sharpe ratio. As I told you, higher Sharpe ratio means maximum risk return, risk adjusted return, right? So I want to optimize that. For that, what I'm going to do is I'm going to use what is called as solver function in Excel. Okay, I'm going to use solver function in Excel. Just give me a second. That is used for yeah. So solver function is available in the data tab in Excel. Okay, can you see here? If it is not available, what you need to do is you need to go to File, Options, Add-ins. Okay, so for me it is inactive status. For you it will be, if at all you have not activated that, it will be here in the inactive application. Click on that, go OK, it will come into active application. So once you activate that, it will be available in the data tab. Can you see this? And click on solver function. Okay, so click on solver function. So I have the solver function tab given here. I'm going to fill this data. So here, as you know, my objective is to maximize the Sharpe ratio, right? So I'm saying set objective cell as 1.87, whatever cell that is, L19. I just clicked on that. L19 cell has to be maximized. Okay, maximized by changing the variable cells. So I'm reworking. Basically, I'm giving the Excel the objective to maximize this by reworking on these 4 cells. I want these 4 cells have to be tried for different combinations. Okay, such that at the end you will give me the Sharpe ratio, which is the maximum that I can achieve. All right. There are some constraints that I will be giving. What are the constraints? That this total should not be more than 100%. Correct? No. So I'm going to put a constraint, add constraint, and I'm saying this one should be less than or equal to 1, or you can even say equal to 1. It should be exactly equal to 1. So you are saying that I want a full investment. If I'm investing 10 lakh rupees, entire 10 lakh rupees should be invested. Okay, not 1 rupee less, not 1 rupee more. All right. So that is a constraint I'm giving, and I'm clicking OK. So basically, I want the Sharpe ratio to be maximized by changing the portfolio weightages and subject to my total portfolio weight to be 1. Okay. All right. So let me say solve. Okay. If I click on solve, take off 30 seconds to solve. Okay, so you see that solver found a solution, and I'm saying keep the solver solution, and I'm clicking OK. Okay, so solver is telling me that I need to invest 77% in TCS of whatever investment that I'm talking about. 23% should be invested in AHEL. That is the best investment that you can do, where your Sharpe ratio can be 2.93. You work out any combination that will not be more than 2.93. This is the maximum that you can achieve with the given given inputs that we have. Okay, so basically that is my optimum portfolio. So what is my optimum portfolio? My optimum portfolio is investing 77% in 77% in TCS and 23% in Apollo Healthcare Enterprises Limited. Okay, so let me just optimum portfolio. Let me also create the graph. So maybe I say data labels are required. I will see more options. Okay, I want the percentage to appear, value not required, category name is required. Yes, leader lines are required. Okay, and we don't need the legend. Remove this. So this should be sufficient. Okay, it almost says HDFC Bank, we don't have to invest anything. TCS 77%, AHL 23%. You can do further formatting according to your needs. Okay, I'll just show you one more small modification we can do. Right now it is saying Tata Motors and HDFC should be invested 0%. What if I want a minimum 10% to be invested in each of them and maximum 30% should be invested in any one stock? Okay, that means I don't want to invest 77% or more than 30% in TCS. So what do I do for that? So go back to your solver, add 2 more constraints. Okay, what is the constraint I'm adding? You can see that Tata Motors, this should be less than or equal to 30%. I'm adding 1 more. This cell should be less than or equal to 30%. Add 1 more. This cell should be less than or equal to 30%. Add 1 more. This cell should be less than or equal to 30%. That is 1. Plus, I'll add 1 more. Tata Motors weightage should be more than or equal to 10%. Right? Again, another weightage for that, more than or equal to 10%. Add. This cell should be more than or equal to 10%. Add. This cell should be more than or equal to 10%. I don't have to add anything, so I'll click OK. Okay. Now I will say, see what I've given is the weightage should be anywhere between 10 to 30%, not more than that. So, and still I want you to maximize my Sharpe ratio. So now it is telling me that you should invest 10% in Tata Motors. It seems that's the worst stock out of the lot that you can invest. And in all other stocks, it is suggesting that we invest 30% each. This seems to be the optimum portfolio if this is the constraint that I'm giving. You can rework on constraints like this, whichever way that you want to incorporate. So this is one of the easiest method to build an optimum portfolio using Excel. The limitation of Excel is that if you have built this model for 4 stocks, you can only use this template for 4 stocks. If you want 5 stocks, you have to rebuild the whole model. Okay, that's a disadvantage that you have. That is where tools like R and Python can be used to process any number of stocks. Hopefully, we'll see that in the upcoming session. Thank you for joining.